All right, so we started off with a couple of segments, if you recall. I translated those two segments using two different translate methods. One of the translate methods created new points. That was the one that did for S1. The other one translated the original points. So since the first one created new points for S1, the original P1 and P2 were unchanged. And since the S2 segment translated its actual points, that affected the original P3 and P4. And then, oh, wrong class. And then I got point A and point B from segment 1, and I got segment 1's name. We translated point A, and we assigned a new point to point B. So the question was, okay, what happened to the segment? If I get the segment's points, I translate one of them, I assign another one a new value, what actually happens to the segment? And the answer is the one that got translated actually is changed now for the segment. But assigning a new point to B doesn't have any effect on segment 1's point B. It just points that capital B somewhere else. It doesn't change what lowercase b from segment 1 does. And then, of course, assigning a new name doesn't affect the S1's name either. All right. Let's see. So what I want you to do is actually go click on the second link in the daily plans document, the memory diagram drawing. So I told you I would give you some practice doing this today. This would be an opportunity to pull up Cami, I guess, right? Question mark? If you do point.translate without replacing point with an actual point, so like you use capital P point, the name of the class, you can't. Since translate's not a static method, you can't do that. That would just cause an error. Okay, good question. Let's see, I'm going to present my other screen here so that I can actually draw it. Let me open up the document first. Okay, we got that document open. It's a PDF titled 5.6 Objects, Primitives, and Parameters. So this one dives a little bit more into, here, let me move my meet screen to my other screen here so I can actually see what's going on. If you have any comments. There we go. Okay, so this one dives a little bit more into the difference between objects and primitives. Okay, so I'm going to walk you through a couple of these, and then maybe you can complete a couple on your own here. We'll see what you come up with. So number one, if I was drawing a memory diagram for this, I would just do like X, Y. When you draw memory diagrams for primitives, you don't draw arrows because primitives aren't references to an object. They're just like hard-coded things in memory. So X is assigned 5 initially, Y is assigned the value of X. So here's the big difference. Like, if you're gonna pay attention to anything here with primitives, here's where to pay attention. When I assign y the value of x, it makes a copy of the 5. It doesn't do like it does with objects. With objects, it just be like, okay, I'm also pointing here. And that's not what happens with primitives. Y gets a copy. So then in the third line of code, x is changed to 10. So whoops, well, whatever, I guess that works fine too. X is changed to 10. I meant to just cross it out with my pen, but that works too. And so now x is 10, and that's it, right? The value of y is not changed just because x was changed. Does that make sense? Hopefully this shouldn't be a surprise to you. Like changing the value of one variable doesn't change the value of another variable just because at one point there was a copy. Okay, so now let's compare that to the car situation. So I have a car class. It's a car has a model, I guess, make and model. This would be the model, and a color. Okay. So when we make a C1, it points at a car object. Okay. And in that car object, there is a model variable. Well, that didn't work out. I lost my stylus, like, I don't know how long ago, and I haven't been able to find one that works for Windows computers at a local store, and so I've just been drawing my finger, and it sucks. So this model variable is a string, so it would point at a string object that has, Ultima in it. I'm not going to write that out. So that's a string object. And it has a color variable, and that points at a color object, which is white. Yep. Oh my gosh. Okay, so then C2, kind of the same idea. We make a new object, and I don't really do anything. Okay, so you get the idea. I'm not even going to draw the rest of C2 because that's not really the point of this one. But it has new values, right? It's got its own model. It's got its own color. The point of this exercise is car C3 equals C1. So this, again, here's the big point, the difference between objects and primitives. When we did primitives in number 1, y just got a copy of x's value. When we have objects here in number 2, it doesn't make a copy. It just points C3 at the original. And so then when I do C1.setColor, okay, we change the color of the C1 object. So now it is yellow instead of white. All right. So we go down to problem number 3. For the code above, what's the output for C3.getColor and C3.equals C1? We haven't talked about dot equals a ton, but I think it should make sense as to what's happening here. All right, in the chat, what is the output for C3.getColor? Go. Get involved, do some stuff, answer the questions. Okay, good. Nice. Yeah, RGB is so weird. How does wait, is it RGB or RBG? It's RGB, yeah. How does red and green make yellow? So dumb. Anyway, your answers are correct. The value of car three's color is yellow because car 3 and car 1 are, what's the A word? Ooh, we didn't use this word on Tuesday. I used it. What is the A word for when two variables reference the same object? I forgot to use this word on Wednesday, so that's why we're struggling here. There we go. Aliasing. C1 and C3 are aliasing. They are two names for the same object. All right. Okay. Let's look at number 4 here. Number 4, we're getting into a couple methods. All right. When you use methods, the variables are in like separate lands, right? And we're actually going to talk more about this. That's actually the topic for today is what's called scope. Scope is the word for where can I see this variable from? Where is it accessible from? Is it a local variable and it only exists here? Is it a global variable that like you can access throughout the entire class? What is the scope of this variable? Okay, so I'm going to make a little box here for main. Okay, this is main. And then I'm going to make a little box here for do the thing. All right. Do the thing and main are completely separate methods, and therefore they have different, they're different localities, I guess. All right. So in main, we have an A value that is 9. We have a B value that is 13. Main calls do the thing. Do the thing has two parameters, X and Y. So X and Y are both local to do the thing. If I tried to use X and Y in main, it would say that those variables don't exist. If I tried to use A and B in do the thing, it would say, yeah, those variables don't exist. All right. Okay. What is the value of X though? Do you see where it calls do the thing here? In number 4? Yeah, the value of X is 9. The value of Y is 13 because we called do the thing right here and sent it 9 and 13. So that's what the values of X and Y are because those are the parameters of the function right there. We doing okay here? Now, once again, these are primitives. They're integers. So X and Y aren't pointing at A and B. X and Y just get copies of A and B. So in the code, we do if X is less than Y, we do X equals Y. Okay. So cross out the 9 and do 13. And then we do Y equals X. So we cross out the 13 and write 9, right? No. Don't get tricked by that like on an AP test where it looks like they're trying to swap the values of the variables, X equals Y, Y equals X. That don't work because once X equals Y, it's 13, and then you try and copy the 13 back over and it's still 13. So that don't work. You with me on that? Okay, so then the question is in number 5, if I print out A and B in main, what's going to get printed? The answer is 9 and 13. A and B have not been changed because A and B and X and Y are separate. Capiche? Okay. All right. I guess I want to do one more here because this is passing an object to a function. All right. Number 6. Once again we've got main. Yes, David, it would. Good question. And then we've got change color. These are two different worlds, two different methods. We have in main, we have a C1, and it points at a car object. That is an accent. Huh. So once again, it has a model and a color, and this model and color point at string and color objects. Okay. The model is an accent that is red. Okay, we call change color. Over here in change color, we have a variable called C. Instead of getting a copy of the car, it is pointing at the car. This is the difference between primitives and objects. So this is aliasing the car. So when I change the car's color, now the color of the car is actually changed. So the car is now blue. Now, if in this change color function, instead of doing c.setColor, I just did like c equals new car, okay, that would not change what's in main. It would just point c at a brand new car. Okay? So that's the big difference between calling a mutator method and just assigning a whole new object. Other questions?
So is car C a whole new car as well?
It depends. If in this code, no, it is not. It is just a reference to the original object.
Okay.
So, now, the variable names themselves are still local to each method, right? I can't use the name C in main. I can't use the name C1 in change color. But C1 and C are both referencing the same object. Any changes made to one will affect the other. Again, unless I assign a completely new car to one or the other, then the aliasing would be broken if I ever assigned a new object. Good? Okay, all right. I will leave that for you to finish up, and then I'll give you the solutions next week on Tuesday. We need to quickly move on. I'm gonna have to dip into your individual time here a little bit today, unfortunately. Okay. Next, I would like you to bring up the Math Magic class. So click on the first link. Yeah, I'll do that. Okay. The last thing that we're going to hit here in chapter 5 is using the keyword this. I'm going to go through this pretty quickly because we don't have much time, and we've also talked about the word this quite a bit already. Okay, I have in this file here, I have a class called MathMagic. MathMagic objects have 2 integer values. They also have an ID, and then the class itself has a tracker. Okay. The point of the tracker is to keep track of how many MathMagic objects have been created. And then when a MathMagic object is created, it gets a new ID based off of the tracker. Does that make sense? So the tracker is going to count 1, and then that new MathMagic object will be like, I'm ID number 1. And then the tracker is going to count 2, and then the next new MathMagic object will be like, I'm ID number 2. Okay. And so then there's there's a method called MathMagic Go, and there's a toString. All right, there are logic errors in this program. Okay. When a MathMagic object is created, it's supposed to get random values, and those random values are sent to the constructor and assigned to the instance variables. However, the program does not work. If you hit play, um, 3 MathMagic objects are created, and they all have IDs of 0 and values of 0. Okay. So I want to, there's like three things that we need to fix here. I want to fix those and make notes on what the issues were. Okay. First question though, what is the smallest possible value when I create a MathMagic object? So when I call the MathMagic constructors, I call the default ones. The default constructor makes random values for val1 and val2 and sends them to the other constructor to be assigned to val1 and val2. So my first question is, what is the smallest possible value for val1? Oh, David, I didn't see your second question there. Can you create a copy of C1, or would you be forced to do something like new car? Yes, you'd be forced to do that. Yes, 1 is the correct answer. That is the smallest possible value for val1. What is the smallest possible value for val2? Ten is correct there. What is the biggest possible value for val1? This one's a tricky one. The biggest possible value for val1. It is 10. It is 10, because when you truncate this 10, when you multiply by 10, the biggest value you can get is like 9.99, and when you truncate it, it goes to 9, and 9 plus 1 is 10. A good way to remember this is that the lowest possible value is this number. So the lowest possible value is 1. This really represents the different possibilities for numbers rather than like the size, I guess. It's just how many different numbers can be created when you're using an integer. So the possible values are 1 to 10, which is 10 different numbers. The lowest possible value for this one is 10, and there are 10 possible numbers, so the largest possible value is actually 19. 10 through 19 is the possible values for val2. Yes, it is impossible to get the max number, correct. Correct. Okay, first of all, again, the point of this activity is how do we use the word this? There's a few different ways to use the word this. One of the ways to use the word this is to call another constructor. That's what's happening here. Okay? So you might want to make a note of that. Keyword this calls the other constructor. So basically what's happening is these two random values are being created and sent here to the other math magic constructor. All right. So let's look at the issues of this class. Why are all the values 0? How come these random numbers aren't actually getting assigned? Because they should be at minimum 1 and 10. So why aren't values actually getting assigned to val1 and val2? And it has to do with this constructor. Keep in mind we're talking about how to use the word this. How would you fix this? It appears as though nothing is getting assigned to val1 and val2. The instance variables val1 and val2. Correct. We need to use the word this to specify that we're talking about the instance variables val1 and val2, not the parameters val1 and val2. It turns out if you have instance variables and parameters with the same names, it's always going to reference the local variables as opposed to the instance variables, unless you specify this. Okay? Now the program knows we're talking about this val1 and val2, not the local parameters val1 and val2. So now if you run it again with this keyword in there, now our vowels have actual numbers. Yay. Okay. All right. Second issue. The ID values are not increasing. We should have IDs of 1, 2, and 3, not 0, 0, and 0. Why aren't our ID values getting assigned something? I add 1 to the tracker. Tracker is a static variable. Therefore, it should be if it belongs to the class, and therefore it should go up for all MathMagick objects. So any MathMagick object that's created should have an increased value of tracker. How come the ID value is not getting assigned a non-zero number? Use this where? Correct. Yep, I made a new ID variable as opposed to using the instance ID variable. Okay, so once again, I'm kind of conflating local variables with instance variables. This is a completely separate new ID variable instead of referencing the instance variable ID. Okay? So I need to do this.id equals the tracker. By the way, you can't use the keyword this with the tracker variable because it's a static variable. And there we go. Now that we have our keyword this in there, now our MathMagick objects have IDs based off of the tracker. Huzzah. Okay, last one. So this is used to call constructors. Just a little review here. This is used to call constructors. It is used to reference oneself and one's instance variables. And then the third use that we're going to look at here is with the MathMagic Go method. I have two MathMagic Go methods. Therefore, the MathMagic Go method has been overloaded. Okay. Notice the difference between the two. One of them is static and requires that you send it to MathMagic objects. The other one is not static, so therefore would be called using a MathMagic object like this here in main. See this, see this, see this, m1.mathmagic m2. So m1 calls MathMagic, m2 is the parameter. What I want to do is I want to use this other MathMagic method to do the math. So instead of rewriting the math, I want to just use the other method to do the math for me. David, no, it does not. Any reference to this has to be to a instance variable. Okay, so first, how do I call this MathMagic Go method? Well, since it's in the same class, you just call it. Just go MathMagic Go. And some of you were struggling with this, I think, on the reduce method in the fraction class. How do I call this reduce method? You just call it. It's in the same class, you just call it. Okay, I want to send this other MathMagic method two things. All right. One of those things is going to be other. Does anyone know what the first one is going to be? And this is kind of like answering Jesus in Sunday school. If you've been paying attention to what the answers have been so far to all my questions during this lesson, you should know what this answer is.
Is it this?
It is this. And it is not this something, it is literally this. Okay? This is a reference to the object itself. So if you need an object that references, the thing, then it's just this. Okay? So this is a reference to the actual object itself. That's why we use it to reference variables like this.id and this.val2, because this literally is the object. So I'm saying my own ID, my own value, or in this case, myself. I'm sending myself to this other function. Does that answer your question, Uma? The second constructor? What? You mean the second method? Yeah, okay. So let's look at it real quick. This will be it here. If I call it using M1 and M2, or here I'll just do, just to give you two examples, M2 and M3. Okay. All right. When I use it with this one, let's think about this together. First of all, this one, when I use it like this, it calls the non-static method. Right? So in this first example, this is a reference to M1. Yep. Other is a reference to M2. Yep. And then when I do it this way, this is a reference to M2. other is a reference to M3. I can also just straight up call the static method if I wanted, mathmagic dot mathmagic go. Now it's giving me an error immediately because it's like, hey, mathmagic go needs 2 parameters. So I can just go like that instead. If you want to put those examples in your code, you can do that. So basically I wrote the same function twice. And they very much do the same thing because here we should get the same output for line 13 and for line 15 because the non-static method is literally calling the static method to do the work. Okay, so we get the same answer for when we use M1 and M2 with mathmagic go. So yeah, that was the whole point. It was, yes, they do the same thing. It's just 2 different ways to call the same function. I can call it using a static function. I can call it using a non-static function. So this would be like in your fraction class. Remember your fraction class? If you had 2 fractions named f1 and f2, and you wanted to add them, one way to add them would be f1.add f2. But you could also write it so that you could go fraction.add f1, f2. And it would just be a preference for the designer what route they would want to go with that. But since those functions do the same thing, there's no point in literally writing the fraction code twice. You would just have one function call the other.
Why is fraction.add f1, f2? Why is that like deemed like better? Not better, but why would someone use that?
I don't have a good answer for that with this scenario because you would have to make fraction objects in order to do any of this. Like the whole point of a static method is so that you don't have to make objects. So I can go like math.square root 25 without having to do math, my math equals new math 25 and then do my math dot square root, right? That's a pain. So instead we just call math dot square root. With this isn't a great example functionally because if you're making fractions, you would have to make fractions. So this would be just as easy or easier than this. So yeah, I don't have a good answer to that question. Sorry, it wouldn't be better. Okay, I've gone over time here for our class time. For the rest of the class period, I want to do groups today. I'm going to break you into groups of 3 and have you work on topic 5.4 to 5.7 quiz. What you're going to do is you're going to look at a set of 3 classes, deck, card, and bankroll. And this is very similar to what I did with segment and point the other day. Some segments will get changed, some points will get changed. Here, some cards will get changed, so the bankroll will get changed. And you're going to try to determine how those changes affect other objects, right? So I'm going to break into groups of 3. I want you to have your microphones on. I want you to look at the classes and discuss the questions together and complete the quiz. Yes, it does, David. Without the slashes, you'd put commas instead of slashes, but yeah, that works fine. Okay, breakout rooms. 4 breakout rooms. What? What? Why? What? This doesn't make any sense. Oh, this is such a pain. Sorry. Go down. All right, group three, group three, group three. All right, we got one group of 4, it looks like. That's okay. Okay, all right. 3 groups of 3, 1 group of 4. Again, turn your mics on, please, and discuss with each other the answers to these quiz questions. Good? If you have questions, raise your hand. I'll pop in. No. Oh, okay. I went away from the breakout room button, and then I thought I was going to have to remake them. Here we go. Bye-bye. Mm-hmm.